Hello, everybody. My name is Gregor Moos. I am working as a manager for digital tools at Voigt Paper in Heidenheim. I'm going to talk about connecting design with customer demand, driving spare part and aftermarket business by applying APS technology in a web shop. Before we start with the whole topic, let me shortly introduce Voigt Paper. Together with our partners, we build machines and plants that produces paper. We build new machines, we make rebuilds, but we also take care of our spare and wear part business and services. What brings me to our topic. What was the motivation to start the whole project? It all started with this question: which part is it? We know that our customer asks this question day by day. And we believe that if our customer can answer this question as fast as possible and as easy as possible, they're gonna order more spare and wear parts in our web shop. So our North Star is Voigt Paper wants to increase sales of spare and wear parts through a distinguished, fast and reliable part identification. Within this presentation, I'm going to show you 3 examples how the Autodesk platform services help to achieve this gain. We're going to talk about the 3D visualization, the visual part recognition, and the graphical navigation at Voigt Paper Webshop. Let's start with the 3D visualization. Where do we come from? Imagine you're a customer of Voigt Paper and you want to rebuy one of your spare and wear parts. You enter the web shop and what you see so far is the principal product image on the top left, some text description, and some technical data in the bottom. That might be enough to identify your part and to make you feel good to buy these parts. But what if we use our 3D models to improve this whole user experience? The idea was to use our 3D models to replace our principal image by an explicit product image. We're going to keep the text description and the technical data, of course, and we add a 3D viewer. So every user can identify their parts much better and by that, hopefully order these parts more often and faster than before. How did we realize this approach? At Voigt Paper, we use SAP as our storage for 3D models and of course the SAP Material Master. The SAP Material Master describes the part in SAP, and we built an interface within SAP that checks if our SAP Material Master is connected to a 3D model. Furthermore, the interface checks if there is a neutral file format for the 3D model. We work with steps. If there is no step for the 3D model, the interface will start to trigger the step creation. After that, the interface forwards the step file to the Autodesk platform services, especially in this case, the APS viewer. The APS viewer converts the 3D model to a web component, and this web component will be implemented in our web shop. The result of this approach is that we made it happen to have 80,000 plus parts visualized in our web shop. And another 200 parts per month are continually coming to the web shop. Now, why did we choose APS to realize our approach? We did a benchmark. We compared a professional visualization company with a company and its solution that is providing a 3D CAD catalog for norm, standard, and catalog parts, and APS. And the reason why we chose APS before the others were the three on the right side. I'm not a coder, but the IT colleagues who take care of the webshop and its maintenance told me that the API is very, very easy to implement. It took them 1 or 2 days to code the viewer and to code the link between the web component and the web shop. The second, and maybe most important, reason is that it is the cheapest solution. You only pay a 0.1 token per upload, so per conversion of the 3D model. There won't be any further license fee or maintenance fee. And last but not least, the data are secure. The 3D models you see in our webshop are not downloadable. You cannot reverse engineer them or use them for any other purposes. What are our challenges? Definitely data availability. So 2/3 of our parts that are visualized in the webshop are non-3D. That's got different reasons. Our parts have histories. Some go back 40, 50 years, but also for its influence on 3D data is limited. So we are not only selling Voigt own parts in the webshop, we also sell catalog or standard parts, and not for all of them we get 3D models that we can display. So summarizing the benefits of this approach, we believe that this visualization offers our end users a state-of-the-art user experience. It helps them to fastly and efficiently recognize their parts, and by that, do a first-time right ordering. For Voigt, we think we have a unique selling point by that, but we also decrease our internal offer because our customer service center can also use these visual tools to identify parts if external customer come with a request or demand. And by all of that, we believe that we will increase our sales by the time. Let's come to the second point, visual part recognition at Voigt Paper Webshop. Once we had our 3D models in the webshop, we thought, what else than visualization can we do with this data? And more or less the logical consequence of it was to use it for a visual part recognition. Where do we come from? Before, we only had our text search, where you could write in, for example, valve or bearing house or whatever you are looking for. Or you would click yourself through some trees managed by some headlines. A new additional possibility to find parts is the visual part recognition. The user can use pictures that are whether taken or uploaded and search by that. The search can also be enriched by some text, and by that find your part very fast and very easy. How did we realize this approach? We work together with an external AI company that provides the visual part recognition capability. And they would use our 3D web components to make this happen. Again, which benefits do we see? The state-of-the-art user experience, fast, efficient part recognition, first-time right ordering, and a unique selling point, increased sales and decreased internal effort. Last but not least, graphical navigation at Void Paper Webshop. Besides the graphical part identification, we thought about how else we can use our 3D models and the APS technology to improve our user experience in the webshop. So where do we come from? If you navigate in the webshop, you have whether categories like bearings, connecting components, whatever, or you can navigate by your process steps, automation, paper machines, then jump into one of your sections or parts you want to buy. So what if we use the APS technology to enable the user to navigate in a 3D model, click to the relevant section, and jump off to a web shop? The APS viewer makes this possible. We use space models of our paper machine, and we connect them via a knowledge graph to the relevant data. This is a demonstrator. It's not applied in the webshop yet, but we are about to make some customer tests soon. How did we realize this approach? The APS viewer, as you have seen, is the visualization tool. And the 3D data come whether from Inventor or via Navisworks. The APS viewer is connected via a knowledge graph with relevant sources like our e-business platforms, Comos or SAP, and aggregates the information to make it clickable in the viewer. This offers an intelligent 3D model that will create a very new user experience for our end users and customers on site in the paper machines. And again, we see the same benefits as before: a state-of-the-art user experience, fast, efficient part recognition, first-time right ordering, and a unique selling point, decreased internal effort, and increased sales. Thank you very much for listening to my presentation. Please come back to me if you have questions or comments.